Hello. Is this working? Maybe. Hey, it looks like she is. My audio is for some reason doubling up. I have no idea why. That's not a great thing. What is she gonna do about it, though? Doesn't sound like it's doing it anymore. That's a shame. Okay, we're getting real close. I thought we'd have it done, but this all seemed to be a bit longer than I thought it would be. Yeah, so we're just doing graceful shutdown and cleanup, and this will be the last little bit. We'll look at the appendix, but after all of this, we are done. At which point, we get to finally look into Rust. Rust? My god, I am incredibly tired, but that's not changed. That's been the entire time. Half a year I've been tired. Anyway, we'll get to start looking at the Lemmy code base after this. I think I am good enough to start figuring that out now. It's been way too long. Could have done this in like 2 weeks, I guess, if I just did it daily or something, but hey, we got through it anyway. Alright. I'm honestly just gonna start up. Might be a short one because after this, there's not much more we can decide to do. We'll read an appendix or two, but maybe not. The appendices are keywords, operators, and symbols, so on and so forth. I don't think that's useful. But hey, let's go. Graceful shutdown and cleanup. The code in listing 2020 is responding to requests asynchronously through the use of a thread pool, as we intended. We get some warnings about the workers, ID, and threads fields that we're not using in a direct way that reminds us we're not cleaning anything up. When we use the less elegant Control-C method to halt the main thread, all other threads are stopped immediately as well, even if they're in the middle of serving a request. Next, then, we'll implement the drop trait to call join on each of the threads in the pool so they can finish the request they're working on before closing. Then, we'll implement a way to tell the threads they should stop accepting new requests and then shut down. To see this code in action, we'll modify our server to accept only 2 requests before gracefully shutting down its thread pool. Implementing the drop trait on thread pool. Let's start with implementing drop on our thread pool. When the pool is dropped, our threads should all join to make sure they finish their work. Listing 2022 shows a first attempt at a drop implementation. This code won't quite work yet. Alright, so in libdrs we have implement drop on thread pool. Alright, do we have any other impl blocks for thread pool? Yes, we do. Okay, let's just implement drop. I'm going to put this at the top. Nah, I believe this should probably be on the bottom, honestly. Oh, no, we have to... I am sorry. This impl block requires that we... Yeah, I'm sorry for that. Got ahead of myself. Implementing drop for thread pool, having the function drop, taking in a mutable reference to self, and inside this we are doing a for loop for worker in mutable reference to self.workers. Right, so workers will be each individual workers in the mutable set of workers here. Workers being a vector of workers. Why is workers never used? Sure. We are going to print one, telling it, hey, we're shutting down. Shutting down. Worker. Then we're just telling it exactly what worker we are shutting down. After which, of course, worker dot thread dot join, and we are going to unwrap that. If it fails to join, we will error out. Ooh, that's why it isn't compiled. Cannot move out of worker.thread, which is behind a mutable reference. Move occurs because worker.thread has type join handle, which does not implement the copy trait. Of course it doesn't. How do we do that? I'm right. Worker.thread.join.unwrap. We are copying that due to the fact that we're bringing it in this location. Huh. I can't think of how we would change that, to be honest. Right? First, we'll loop through each thread pool. Workers. Sorry, we'll loop through the workers inside of thread pool. We use a reference, which is mutable for this because self is a mutable reference. We also need to be able to mutate worker. For each worker, we print a message saying it's shutting down and call join on that thread. If the calls to join fail, we unwrap and panic to just ungracefully shut down. Here's the error we get. Yep, we can't move it out because it's a mutable reference. Sorry, which is behind a mutable reference. Alright. Join handle, which doesn't implement copy trait. Join takes ownership of the receiver's self, which moves worker.thread. Is there an issue with moving worker.thread here? I mean, of course we can't because this is Rust, but... Right, the error tells us we can't call join, because we only have a mutable borrow of each worker, and join takes ownership of its arguments. To solve this, we need to move the thread out of the worker instance that owns thread, so join can consume the thread. Right, so the word here that we're looking for is consume. When we want to move ownership in this fashion, I should be Googling something along the lines of consume, if I can't remember exactly how to do it. We did this in listing 1715. If a worker holds a thread, an option thread join handle, instead, we can call the take method on the option to move the value out of the sum variant and leave a none variant in its place. In other words, a worker that is running will have a sum variant in thread. And when we want to clean up a worker, we'll replace sum with none so the worker doesn't have a thread to run. So, we know we want to update the definition of worker like this. Okay, so in this specific case, we do in fact need to refactor worker as like a concept. Okay, sure, whatever. You're going to want an option. Oh, this is what they're talking about when they say type masturbation. We're going to want an option. Of course, this will not work. The option is the owned piece. However, we can take out this join and replace it with a non-variant. Let's lean on the compiler. Okay, it's telling me to lean on the compiler, so what are we looking for? Hello. Yep. Yeah. So, just a moment. Sorry. Sorry about that. Here we are. Right, so what does the compiler say? We have cargo run. Let's try this. No method name for join found for enumerable option in the current scope. Well, of course, yes. So we're going to have to unwrap it in some fashion or take it out. The join already exists in type. Yep. Consider using option expect to unwrap the join handle value. Panicking if the value is option none. Right, yeah, that's fine. That won't just work though, right? That won't just be fine. No, of course not. And of course this. Some. It'll have to be some. Is that just literally going to work? How do we make a sum? I cannot remember. Is that correct? I can't remember. How to make a sum variant. Is it just like a, what is it, result.sum? Sum? Expected. Yeah. So what's the problem? What parsing field struct? Missing name field thread of initializer of worker. Missing thread. Yeah, thread is now an option. Yeah, I guess that's wrong. I really want to be able to just do this, right? Expected. Yeah, sure. Do I have to bring this in? No, it's right there. You have okay and error? Maybe it's not maybe option, of course. It's option, not a result. It's an option. Option has none and some. Okay, that is correct. However, not really. I guess I don't know what I'm doing. There. Right. Method not found. Mismatch type. Thread. Expected option. Found. Join handle. And same here. Let's address the second error, which points to the code at the end of worker new. Worker new. I don't have an error. What? Implement worker. Okay, so in impl worker, worker ID thread, some thread. Okay, so the option, yeah, okay. Fair. That'll work? No. It needs me to name it? Why was it fine with thread? Because it was the same name, I'm guessing? Alright, sure. Is that really the issue? That is the issue. So, this would still work, but it's like an ID error. If thread was originally that, like if we were to, where's thread? Right, where is thread created here? Let thread equal thread. Right, if we just did this, would that work fine? Would that work fine? Yeah? Okay, yeah, so it is literally just the name. I have forgotten this because it's been months, and I've not really coded Rust outside of this. But I guess this really does depend on the name of it. I guess that does make sense, but why not have it so that we can just input the correct values into the correct places? I see no reason for that. Alright, let's go back to the normal thing, but I did push some memory into my head here. Okay, that's an issue. So is this. Ah, so this isn't okay. There. There's another error somewhere, of course. Right, so let's take its advice, just compile and get the error. Same issue. Join doesn't have the correct thing, you can't do that. So, method not found on option handle. Expecting option none. Expect reason join. Oh, yeah. I keep messing up results and options. That's something which I keep mistaking. Failed to receive worker thread. Does not work. Right, sure. Let's just read forward because obviously I have forgotten something. The first error is in our drop implementation. We earlier mentioned that we intended to call take on the option value and move the thread out of worker. The following changes will do so. Right. Yep. Oh, we are using an if let instead of an expect, of course. If let sum thread equals worker. Oh, okay. Yeah. Takes the value out of an option, leaving a none in its place. Yep, that describes what we were doing previously. So in this specific location, where we find ourselves in a situation we want to take a value out to do work on it, it'll never be used again, specifically in a drop implementation. We can utilize this to uh, we can change it to an option which can have done, essentially just signaling and forcing every compiled piece of, sorry, every bit of Rust code to fix any issue with it not having a value. We can use take to take out this value, own that value, and replace it with none, thus removing it from the cycle and utilizing the none variant on any place where it could be used after this. Okay. Thread dot join dot unwrap. Good stuff. That's still a failure. Yep, it's supposed to be a failure. That doesn't change the issue at all. Cannot move out of worker thread, which is behind immutable reference. Help, consider calling .asref or asmute to borrow the type's content. We don't want to borrow, we need to own. If let some thread, worker thread take. As discussed in chapter 17, the take method on option takes the sum variant and leaves the none variant. We're using the iflet to destructure the sum to get the thread. Then we call join on the thread. If a worker's thread is already none, we know that worker has already had his thread cleaned up, so nothing happens in that case. Okay? Sure, whatever. That doesn't fix the error at all. And I honestly cannot think of an... This has changed nothing for us, to be clear. This is a better way to do it, of course. I can understand why, but that still does not fix our error in any way, shape, and or form. Yes, it does. I'm an idiot. Yes, it does. It simply does. I was wrong. I forgot to save and thus got the same error in a similar place. So it does work. This did take ownership. Thread is now owned by this this scope, the drop function. Okay. I was incorrect. I had to save it. I feel kind of embarrassed. But hey. As discussed in chapter 17, yep. Signaling the thread to stop listening for jumps. With all the changes we've made, our code compiles without any warning. However, the bad news is the code doesn't function the way we want it to yet. The key is the logic in the closure run by the threads of the worker instances. At the moment, we call join, but that won't shut down threads because they loop forever looking for a job. If we try to drop our thread pool with our current implementation of drop, the main thread will block forever, waiting for the first thread to finish. To fix this problem, we need to change the thread pool's drop implementation, and then a change in the worker loop. Yeah, there needs to be some flag in the worker loop specifically checking every single instance whether or not this is droppable. Oh, this is now a none variant. Right, this should be the changing... no, never mind. Right, so now that the thread is none, we can simply check on the thread equaling none in the worker loop, I assume, to drop it. Right? Is that possible? That's what I'm going to assume. Like, this won't just wait. This will run eventually, so... Huh. First, we'll change the thread pool drop implementation to explicitly drop the sender before waiting for threads to finish. Listing 2023 shows the changes to thread pool to explicitly drop sender. We use the same option and take technique as we did with a thread to be able to move the sender out of the thread pool. Right? So within sender, we are changing this to an option which holds our multiple producer single consumer. We are then going to, are we going to use an iflet? Sure, probably. I don't see why not. Nah, it's an as ref. Okay. Yeah, because we only need a reference here. Right. Goes to show I'm not learning as much as I think. That's fine. Now inside of the drop implementation, now we're creating a new drop implementation for thread pool. No. No, we are not. Why am I... Okay, whatever. Right, so we are going to drop the self.sender, and we are going to take ownership over that. Right. Dropping sender closes the channel, which indicates no more messages will be sent. When that happens, all the calls to recv that the holders all the calls to recv that the workers do in the infinite loop will return an error. In listing 2024, we change the worker loop to gracefully exit the loop in that case, which means the thread will finish when threadpool drop implementation calls join on them. Okay, this is 2024. I always hate using errors as messaging. I think that's an idiotic idea. I think that's really dumb. Personally, I would prefer strongly you not do that. All right. So within here, we are going to create a new variable called message, which will be receiver.lock.unwrap. Oops, why did I do that? Lock.unwrap dot recv. Attempts to wait for a value on yep. Sure. Sure. Right. Now we are going to only do the rest of it. That's no longer really needed, is it? Yeah, okay. I wasn't really paying attention, but what we are doing is we are replacing job with that. I didn't need to type all that out again. We are replacing job with message. We are no longer unwrapping it, and we are utilizing the option. Right, so we are going to print line, worker, ID, got a job, execute. That's not how you spell executing. That shouldn't be, sure. Now this is on the OK, of course. And on error, holding anything, you're going to print line, saying worker, ID, disconnected, shutting down. Well, I guess that's not really doing an error, is it? We actually aren't, oh, utilizing an error, are we? We're just, if the message gets none, that's not really an error. I guess that's passing errors as options. Yeah, that's passing an error as an option, yeah, okay. Yeah, so we are really using errors, but it seems that Rust is built up much more for that. Alright, that makes a lot more sense, sure. Then we are going to run job here or break. Okay. Don't think that's changed at all, nope. See this code in action. Let's modify main to accept only 2 requests before gracefully shutting down the server as shown in listing 2025. Right inside of the function main, we are going to create a new thread pool for stream listener incoming. 2. Oh, dot. Yeah, sure. Oh, yeah, so we're only going to take 2. What? I don't know what's happening here. So it can take self or size, creates an iterator that yields. Okay, yeah, so take creates an iterator anyway, and if there's only one, it doesn't need the iterator buzz down to the actual value. Okay. Yields elements until n elements are yielded, or the. Okay, yeah, I see. Alright, so we're only going to take two. Two. And is that all? Yeah. Shutting down. You wouldn't want a real-world web server to shut down after only surfing 2 requests. This code just demonstrates what a graceful shutdown and cleanup is in a working order. Sorry that this works. This only shows that what we just wrote works. The take method is defined in the iterator trait and implements the iteration to the first 2 items at most. Okay. Yeah, I am an idiot. Take on an option or a result. Sorry, yeah, only on an option, I guess. Does something entirely different than take on incoming, which incoming passes out an iterator, which has take on it, which does a similar thing, I would assume. It does give ownership, so yeah, okay. Okay, sure. The take method, yep. The thread pool will go out of scope at the end of main, and the drop implementation will run. Start a web server with cargo run. Huh, where is that? Yeah, I did something bad. When did we change that? Out of curiosity. When did I miss that? Inside a worker, drop thread pool, inside a thread pool, where's new? Yeah, here we are. So yet again, we do need to. I need to get that working. I'm going to do that. Yep, and that'll be sender is equal to sum sender. Boosh. Right, now that should work fine. What are we on again? 7878. That's not what I wanted. Just a moment. Probably shouldn't have work stuff on this computer. Hello. Right, it actually did just start breaking instantly. There's multiple requests were sent. Well, that's convenient. Right. And make 3 requests. The third request should error. Nah, the first request errored out. Because I guess multiple requests were sent. Worker 1 got a job executing. Shutting down worker 0. Alright, so we got worker 0, got a job executing, got a job executing. I guess these are 2 different lines. I put it down twice. I did, absolutely. I can remember doing that actually now. Shutting down. Worker 1 got a job executing. Shutting down worker 0. Worker 2 disconnected, shutting down, disconnected, shutting down. 0 disconnected, shutting down. Shutting down worker 1. And then we get worker 1 got a job executing. Something's a bit fucky wucky here, my boy. What? What? You know what? I don't care. You might see a different ordering of workers than the messages printed. We can see how this code works in the messages. Workers 0 and 3 got the first two requests. The server stopped accepting connections after the second request. And the drop implementation on thread pool started executing before worker 3 even starts his job. Dropping the sender disconnects all the workers on shutdown. The workers each print a message when they disconnect, and when the thread pool calls join to wait for each worker thread to finish. Notice one interesting aspect of this particular execution. The thread pool dropped the sender, and before any worker received an error, we tried to join worker 0. Worker 0 had not yet gotten an error from rec V, so the main thread blocked waiting for worker 0 to finish. In the meantime, worker 3 received a job, and then all threads received an error. When worker 0 finished, the main thread waited for the rest of the workers to finish. At this point, they had all exited their loops and stopped. Congrats, this is our implementation, and it is complete. We have a basic web server that uses a thread pool to respond asynchronously. We're able to perform a graceful shutdown of the server, which cleans up all the threads in the pool. Here's the full code for reference. Yeah, there it all is. We could do more here. If you want to continue enhancing this project, here are some ideas. Add more documentation to the thread pool and its public implementation. Add tests of the library's functionality. Change calls to unwrap to more robust error handling. Use thread pool to perform some tasks other than serving web requests. Find a thread pool crate on crates.io and implement a similar web server using the crate instead, and compare its API and robustness to the thread pool we implemented. Summary? Well done! I'm going to do this, but I'm going to do this on my own time, honestly. I am just incredibly tired today. Well done! You've made it to the end of the book. We want to thank you for joining us on this tour of Rust. We're now ready to implement our own Rust project and help on others. Keep in mind that there's a welcoming community of other Rustaceans who would love to help you with any challenges encountered on our journey. This is the end of the experiment. We are being thanked for it. We hope you got some useful from our additions. We hope you got something useful from our additions. Oh my god. I am so tired. Your partition will help us make Rust better. You can follow Ton of Crates on Twitter if you want to hear about future updates. Appendix. And here are the appendices we had skipped. That's it. This has been a half an hour thing, but I am just gonna head off now. Next, in a week, we are going to start looking through the Rust. Sorry, I've made the same mistake. The Lemmy code base. Let me get the Lemmy GitHub just up. What is on the Lemmy Git? Is it a GitHub thing? Yeah, it is. Alright. Cool. Turn on. Right. So here we got it all. What is it using? Rust mostly, but also some TypeScript, shell other script. I'm guessing that the front end is in here somewhere. Where is it? I'm just going to take a quick look through. We got source, which has all of this is the Rust. What's in the main.rs? We'll check that out. lib.rs. I'm assuming that this is all going to be stuff to push out towards the crate and configs and all that good stuff. Git ignore, git modules. Yep. Documentation. Is that on the actual thing? Ah, it's using the same tooling. Right, so you got for users, for admins, for contributors. You know what? Let's read the overview. Lemmy is an open source project and relies on community contributions to get better. Development happens mainly on the Lemmy GitHub repositories. Communications are done over Matrix. Good. There are the main repositories, which are relevant for contributors. Lemmy, the backend, which is the core of Lemmy, it implements SQL queries, provides the API, and handles ActivityPub federations. Additionally, it sends emails and provides RSS feeds, written in Rust with ActiveWeb and Diesel. The issue tracker is also used for general enhancements which affect multiple repositories. There's also Lemmy UI, the main front end for Lemmy. It provides the user interface you see when viewing a Lemmy instance, written in TypeScript and CSS with the Inferno framework. Ah, Inferno, what is that? I remember that name. What's the Inferno framework? Ah, yeah, I remember this. I hate this, honestly. I don't. Ah, insanely fast, React like library for building high performance user interfaces on both the. Okay, I've seen this quite a lot. There's like 40,000 of these different Rust compatible, Rust like API and components lifestyles. Just like these, sorry, React. These like React clones that come in and they just have a subset of the features of React while utilizing the same design patterns. Inferno is the same thing. It's only faster because they do less. Which, reasonable, understandable, okay, fine. But React isn't that slow. For something like Lemmy, you don't need that much speed. I mean, sure, they're using Rust, which is known for be quick, boy. But like at that point, just use TypeScript. Just use regular. I mean, TypeScript you should be using, but why use some weird framework like this? Is it even open source? Like, what is this? MIT? Yeah, MIT. Sure. Like, there's no reason for this. I don't think so. Okay. Let me Ansible. It's just Ansible. Join Lemmy site. That's just the site for join Lemmy. Good. Lemmy.js client. Client for the Lemmy API, which is used by Lemmy UI. You can also be used by other projects to get started more easily. Oh, is this like JavaScript, TypeScript, HTTP client for type system and type system for Lemmy? Okay, so this is likely. Oh, yeah. So this is how I could create like my own little front end for Lemmy, I guess. That's probably how the apps are doing it. Probably using something along the lines of React Native and then just hooking into this API. I didn't know there was this much stuff in JavaScript. I don't know why I didn't think that, honestly. I could have been contributing a while ago. High-level framework for activity pub federation in Rust. Was originally part of the Lemmy code, but was extracted and made more generic, so other projects can use it too. That's cool as hell. I like that. A high-level framework for activity pub federation in Rust. The goal is to encapsulate all basic functionality so that developers can easily use the protocols without any prior knowledge. Alright, what does the API look like? And of course, it's going to be using, yeah. Oh, no, that's an entirely different thing. Yeah, this is just the auto-gen documentation, I think. Alright. There are many different ways to contribute, depending on your skills and interests. We can report issues, translate, programming, and dev work. You can open a pull request and make changes to Lemmy. In case of bigger contributions, it is recommended to discuss it in an issue first. See the next section to get instructions for compiling and developing the project. Alright, local development. I almost certainly have everything here. Yeah, I got cargo, OpenSSL, package config, Postgres, libs, and curl. Let's just see. That's not what I wanted. Yep, we got it all. Setting up Postgres? Yeah, I got that. Oh, I forgot we had to do that. Wonder why. It's just if we have errors. We have to make a directory, of course. We have to own the directory. or have the user own the directory, and then use that user to run initdb. Oh, no, no. Yeah, never mind. I forgot what -u does. Whatever. Okay. Either execute script/db init or manually initialize the... Right, it doesn't tell us to clone the repository, but we probably should. Alright, actually, I am incredibly tired. I'll fuck something up and I won't remember. So I think this is it for today. Next week, we will